Okay, I'm just introducing what we're going to do is practice. The only way to get functional groups is to practice with them, so I'm going to model it.
All right, here we go. I'm going to pick the easiest two, three to name first, then we'll move on. So first of all, when we look at halides, okay, we need to remember carbon chain names. So you look that up on table P. And then we are looking at this information right here. So when we look, we need a number, so we need an address. And then fluorine becomes fluoro, chlorine becomes chloro, bromine becomes bromo, and so on. Okay? So first, this one is super easy, right? I have 1. So see I find my longest chain of carbons, 1, 2, 3. I don't have any other carbons, so here's my chain. Circle anything that comes off the chain. That's this. Okay. Now, what is this? This is a chlorine, and we just looked it up on table R, and we use chloro, and we need an address, right? So when you look at this first, you would say, oh, 1, 2, 3, it is on carbon number 3. But you would be wrong, because I can also number in reverse, 1, 2, 3, and in that case it's on carbon number 1, and we always want to use the lowest number for the address. So this is a 1 chloro. Okay, how many carbons are in my chain? 1, 2, 3. What is the prefix for 3? Prop. I don't have any double bonds. How can you tell if I drew out these or triple bonds? If I drew out these hydrogens, you would see it's all single bonds. If you aren't sure, draw them out. So this name would be 1 chloro propane. Okay, let's look at this one. Oh, this printed weird. That should be a lowercase r. So I have my carbon chain right here. This is not on the chain. Okay, how many carbons are in my chain? 2, that's F, all single bonds. This would be bromo. It needs an address. Well, I could number it carbon number 1, 2, or in reverse way, carbon 1. Which one do you use? 1. So that's 1 bromo ethane. Okay, let's look at this one. Let's find the longest chain of carbons. Here we go. Circle anything that's off the chain. Okay, and that's chloro. 1, 2, 3, prop. It needs an address. Well, it could be on carbon number 1, 2, or number this way, 1, 2. So either way, it's 2. So this one is 2 chloropropane. So do you see how 1 chloropropane and 2 chloropropane only differ in their address? That's it. Okay. All right, so now we're going to name the 2 kind of harder ones. All right, so look for my carbon chain right here. 1, 2, 3, 4, 5, 6. That's hex. It's all single bond, so it's hexane. Now, I see a lot of hydrogens, but what we're going to do is circle every single thing that's not a hydrogen, because those are the things that are off the chain. Okay, I have to name each one. So this is a chloro, this is a chloro, and this is a chloro. Oh, not a chloro. A fluoro. Silly me. Okay, now we need what? Addresses, right? So I could number my carbon chain this way, 1, 2, and my halogens would be on carbon 3, carbon 4, and carbon 5. Or if I number the reverse way, they would be on carbon number 2, 3, and 4. So I'm going to use 2, 3, and 4 because those are the lowest numbers. Now, what do I do here? Well, when I have 2 of the same thing, we just say di for those, okay? But then how do I decide which one goes first? We literally use alphabetical order, okay? So in terms of the alphabet, chloro comes before fluoro. So how do we do it? Watch this. 3, 4, di, chloro, 2, fluoro, chain, hexane. Phew. So what does this mean? On carbon number 3 and carbon number 4, I have a chloro. True story. On carbon number 2, I have a fluoro. Also true story. And they're all present on a chain of 6 carbons with all single bonds. Ding, 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 ding. Okay. All right. And one more here. Okay, let's see. Find my longest carbon-carbon chain. So try straight across like this. If that doesn't work, then we have to get creative. So 1, 2, 3 this way. I could number 1, 2, 3, 1, 2, 3. Okay, it's still 3. So here's my carbon-carbon chain. Circle everything that's not part of that chain. You know, that's not a hydrogen or not part of that chain. So this is an iodo, right? What is this? Well, it's carbon. And it's 1, so it's meth, but we say YL, right? That means off the chain. Okay. How many carbons are in my chain? 3, so that's prop. All single bonds. You could draw it out if you don't believe me. All right, last step. We are going to put an address. Okay. So they're both on which carbon? 2. Now, technically for the methyl, I don't need an address because if I put the methyl here, it would increase the chain, okay? But in this case, you would not really get marked wrong for putting the number because you are numbering this one. In alphabetical order, it would be iodo first. You absolutely need a number for the iodo because it could be on carbon 1 or 2. And then this 2 is actually optional. You don't really need it, so because you can't have it anywhere else. So usually it would be 2-iodo methyl propane, like that. I'm just putting it this way as you would not really lose points for that. Okay? Okay, now we're going to draw them. Drawing them is so easy. You're going to see how much quicker this is. So, address, address. Di means 2 of the same thing. Bromo is what? Br. Prop means what? 3 C's. Ane means all single bonds. So start with my chain. 1, 2, 3 carbons. On carbon number 1, put a Br. On carbon number 2, put a Br. Now what do? Fill everything else with hydrogens because that's all the name told me. So hydrogen, making sure each carbon has 4 bonds. 1, 2, 3, 4. This carbon has 1, 2, 3, add 1. This carbon has 1, 2, add 3, 4. Now you can write the hydrogens at the end of each of those lines, but remember, if at the end of the line it's a hydrogen, you could leave it off the picture. All right, let's look at this one. What do we have? Chloro is Cl, fluoro is F. Chloro is on carbon 2, fluoro is on carbon 3. Pent means 5 C's. Oop-ene, there's a double bond. Where is the double bond? On carbon number 3. Whew, okay, so let's draw all of the information. Ready? Pent, 1, 2, 3, 4, 5. Let's put a double bond on carbon number 3. 1, 2, 3. On carbon number 2, let's put a chloro. On carbon number 3, let's put a fluoro. And let's fill the rest with hydrogens. Each carbon needs 4 bonds. Ready? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, add nothing. 1, 2, 3, add 1. 1, 2, 3, 4. Now remember, if it's a hydrogen, I can just leave it blank, so I'm going to leave it blank in this one. And here what I want to show you is literally this is a mistake. What number should this be? Even I make mistakes. That should be a 2, right? Because why? This carbon-carbon double bond is either between carbon 3 and 4, or numbering this way, it's between carbon 2 and 3. What's the lowest number of all of those? 2. So it should have been 2 pentene. Okay? But I drew it as it was written. Okay? But that actually should be a 2 pentene. There we go. All right, so to name an alcohol, let's look. To name an alcohol, we need an address. The alcohol functional group is an OH. Okay, so let's look. Always, we have to find our carbon-carbon chain. So let's just start with this one at the top. So it's all connected in one chain, right? Now circle anything that comes off of the chain that's not a hydrogen only, right? So an OH, we just determined that is a functional group of an alcohol, right? And we need an address. So first, let's see how many carbons are in my chain. 1, 2, 3, 4, 5, 6. So that's hex. I don't see any double bonds, so it's going to be hexane. Now I need to figure out what the address for this alcohol is. 1, 2, 3, 4, 5, 6. So it would be on, is it 3 or is it 1, 2, 3, 4? What's the lower number? 3. But now let's look back at this. Do you see how the name says prop? Because there was 1, 2, 3 carbons, and then anol. All right. So hex anol and 3. So that literally means we have an alcohol and the functional group is located on carbon number 3. All right, so let's try this one. Let's look for my chain. Here's my carbon-carbon chain. Circle anything that comes off the chain that's not just a hydrogen. Right here, that's an alcohol. What, how many carbons? 3, that's prop. What address would I use for that? Well, this way it would be 1, 2, or 1, 2. Oh, it's 2 no matter what. So, to name the alcohol prop, anol, that means I have an alcohol. And I got to say where the alcohol functional group is located on carbon number 2. So I have an alcohol with 3 carbons, and the functional group is on carbon 2. All right, let's look at this one because this one is a little bit confusing. Once in a while you might see this one, so just to throw an example like this. Watch, to count the carbons. This is 1, this is 2, 3, 4, 5. Okay, so pent. So this right here is the chain. It's just more accurate to how it actually is shaped. Circle anything that is not part of the chain, that's not simply an H. This is an alcohol, right? This is what? A methyl group, right? 1 carbon. So you got to number them so they have the lowest numbers. So this is 1, 2, 3, 4. So it would be 2 and 4, or this way, 1, 2, 3, 4. Okay, so it's 2 and 4 no matter what, right? So anol, pent. Pent anol. We'll say 2 pentanol and then 4 methyl. Or you could say 2 methyl 4 pentanol. It's really the same thing, and there's just a little nuance here, but it doesn't really matter in terms of this class, which way you're going to name it. So this means on carbon 4 there's a methyl group, and the functional group for the alcohol is on carbon 2. Or this one means on the 2nd carbon we have a methyl group, and on the 4th carbon we have the functional group for the alcohol. It ends up being drawn like this no matter what. Okay, I love these. This is literally probably my favorite part of organic chem, is using the names to draw it. So it ends with anol, so alcohol. Chain of 6 carbons. 1, 2, 3, 4, 5, 6. It has an alcohol functional group, right? That's OH. On carbon number 1. So I could put it here. Could put it on that end, but I can only put 1. And then I'm going to add hydrogens. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Watch this one. 1, 2. This hydrogen is attached to this oxygen. This hydrogen is not attached to this carbon. So this carbon has 1, 2. It needs 3, 4. Okay, be careful of that. All right, this one. Bute, 4 carbon. Oh, what does this mean? Can you guess? What do you think? Well, this indicates alcohol, right? But what do you think di? Oh, 2 functional groups. Oh my goodness. Okay, so butanol, 4 C's. And I have 2 functional groups, one of them on carbon 1 and one on carbon number 2. So I'm just going to put it off this way. This is carbon number 1, because I could number backward, right? This would be carbon number 2. Remember, the carbon is bonded to the oxygen, and then the hydrogen is bonded to the oxygen, even if you just write it as just OH like this. All right. Now add in my missing hydrogens. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There we go. All right, so we're going to name some ethers. What I want you to see right here is I have methyl, ethyl, and then ether at the end. So I have to use that information to help me name it. So let's do this one first. I'm looking, actually no, let's do this one first. So I'm looking for carbon-carbon chains. Okay, so carbon-carbon chain broken up by an oxygen. Carbon chain. So let's just find all the carbon chains. Here's the oxygen, carbon chain, carbon chain. Here's the oxygen, carbon chain, carbon chain. All right, so let's go through and look at how many carbons are in each chain and name it. So we have prop, meth, and they're all going to be YL. Okay, so this is methyl, this is ethyl, this is ethyl, this is ethyl. Okay, now when we are naming it, we could just look at the way that the compound is written and put them in order, and we're going to add ether at the end. So methyl, propyl, ether for this one, right? This one, methyl, ethyl, ether. Now what about this one? I don't write ethyl, ethyl, ether. That sounds weird. So I say diethyl ether. So ether means I have an oxygen breaking it up. On one side I have 2 carbons, on the other side I have 1 carbon. I have an oxygen breaking it up. On one side I have 3 carbons, on the other side I have 1. I have an oxygen breaking it up, and on both sides I have 2 carbons. And that's it. I love ethers. All right, let's draw them. My favorite part of organic. Butyl, 4 C's. Ethyl, 2 C's. Ether, this. Dimethyl ether. So 2 1 C's. Ether has this. So let's draw the first one. Oxygen. On one side I have 4 C's. 1, 2, 3, 4. On the other side I have 2 C's. And then add the hydrogens. 1, 2, 3, 4. 1, 2, 3, 4. Remember this, oxygen can only form 2. 1, 2. Done. This carbon, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, there is butyl, ethyl, ether. Okay, let's do dimethyl ether. Draw the ether. On one side, add 1 carbon. On the other side, add 1 carbon. That's 2 methyls. Add the hydrogens. 1, 2, 3, 4. Oxygen, only 2, so I'm done. This carbon. 1, 2, 3, 4. And there we go. Remember, you could tediously draw H's at the end of each one of these lines, but that is a great assumption that can save you time. All right, we're on to aldehydes next. So let's look at aldehydes on table R. So very similar, alcohols ended with anol. These end with anal, okay? So all it is the number of carbons with anal. How can I tell it is an aldehyde? I have a C double bond O H at an end, okay? So let's look for our carbon-carbon chain, okay? Here, 4 C's in a row, 2 C's in a row, 3 C's in a row. Now, what is the functional group? Okay, well, I have a double bond O and it's at the end. So this, when it's stuck at the end, that whole thing becomes that functional group. So this, right? The C double bond O with an H. It's stuck at the end, so it's just that group at the end. So all I do is name the number of carbons, and I don't have to put an address because I know it's at the end. So prop, anal for this one. For this one, how many carbons in the chain? 4. Bute, anal. This one, how many carbons in the chain? Oops, sorry. 1, 2, F, anal. That's it. Naming aldehydes, easy peasy. All right, let's draw them. Again, my favorite part, aldehyde. Functional group looks like this, right? So all I do is draw the number of carbons and add this on the end. Doesn't matter which end, so I'll do one way and one the other. So oct, 8. 1, 2, 3, 4, 5, 6, 7, 8. On the last carbon, put this. Don't add another carbon, or I would have like changed the chain, right? So just put it on the carbon that's already there. This tells me draw 8, add the functional group. The functional group is this at the end, okay? Now check bonds. Oxygen has 2, hydrogen has 1. Beautiful. This carbon, 1, 2, 3, 4. Done. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. All these like this, right? The end one, 1, 2, 3, 4. Next one, pent, 5. 1, 2, 3, 4, 5. So I'm going to show you, it doesn't matter what end. So I can put double bond O and an H. I don't add another carbon because this literally told me how many carbons to put. You can't go adding extra ones, okay? You just put the functional group for an aldehyde on the last carbon, okay? Then we fill it in with hydrogens. This one we know is complete. The middle ones are all going to need 2. The end ones should have 3 additional lines, okay? That's aldehydes. All right, now we're on to ketones. So let's look at table R for ketones, okay? You could see what the functional group is. We have a C with a double bond O somewhere on the chain. So you can see you have a chain of carbons, and then one of the carbons has a double bond O, and we need an address. Okay, what else do we notice? Pent is the number of carbons in the chain, and unknown. So we got to add unknown. So unknown is my ending for naming, and I'm looking for this, right? So let's look for our carbon-carbon chains. These ones are easy peasy because it's not a lot of branching. So here's my carbon-carbon chains, right? Now I'm going to look for the functional group, right? That's something that's not a hydrogen, okay? Right here, right here, right here. So what do you notice here? This looks like it's a ketone, but look at this. C double bond OH. Wait a second. That looks like this. So sometimes you're going to get tricked. This one, is not a ketone. This one is an aldehyde. Because with a ketone, this double bond O cannot be on an end carbon. So we're going to name this one based on the aldehyde rules. What about this one? Oh no, this one is also an aldehyde, right? It can't be on the end carbon. So this is the only one that is truly a ketone. So this one, 4 carbons, butanal. This one is propanal. Okay, this one, ketone. 1, 2, 3, 4, 5. Pent. Anone. Address. Tell me where the double bond O is. Well, let's number 1, 2, 3. It would be on 3 going this way, or 1, 2, 3. Oh, it's on 3 regardless. 3 pentanone. All right, so what if it looked like this? This one. Carbon chain. Functional group. Okay. How many carbons? That's 3. So that's propanone. Ketone, right? Address, address, address. Carbon number 2. So this is an aldehyde because the double bond O is on an end carbon. This would make it a ketone. That's a very important thing to understand, the difference between ketones and aldehydes. Lots of mistakes are made here, so be careful. When the double bond O is in the middle, it's a ketone. When the double bond O is at an end, it's an aldehyde. So again, be careful. All right, let's draw. So excited. How can I tell these are ketones? Unknown. Okay, easy. Draw carbon chain, functional group address. Carbon chain, functional group address. So let's do octanone. Oct is 8. 1, 2, 3, 4, 5, 6, 7, 8. To make it a ketone, I need to put the functional group on carbon number 3. 1, 2, 3, functional group. That's it, except for adding the hydrogens. This is not done. Please don't leave it like this. So 1, 2, 3, 4, 1, 2, 3, 4. This one has already 4. So the rest of these middle ones get 2. And the end one gets 3. So let's try pentanone. Pent is 5 C's. On the second C, put the functional group. So I'm going to do this one from the reverse just to remind you it doesn't matter, right? Now add the hydrogens. Now it has 4. This one already has 4. Add nothing. There we go. 2 pentanone. Easy peasy. Love the drawing. All right, organic acids. Let's look at table R so we can kind of see what we need to worry about. All right, organic acid right here. I don't have an address, so at least that's not what I have to worry about. Why? Because it's at the end. Remember, aldehyde at the end, no address, right? Organic acid. So it's at the end. All I need to know is how many carbons are on the chain for prop. Then I need to know anoic acid. So I'd add all those parts. And I'm looking for C, double bond O, OH. All right, let's look. Let's find carbon chains first. So that's all I'm going to do. Look for carbon chains. Like this. Ooh, big one. Okay. Now I'm going to look for anything that's a functional group, right? It's not just an H attached to the carbon. So it's going to be this whole thing right here, and then this one, it's right there. Remember, do I need to worry about an address? No, because it has to be at the end, right? All I need to know is how many carbons. 1, 2, 3, 4. I count the carbon in the functional group because remember that was on the chain. So that is but, and then I add anoic acid. 1, 2, 3, 4, 5. Pentanoic acid. 1, 2, 3, 4, 5, 6, 7, 8. Octanoic acid. Easy peasy. All right, now we're going to draw some. How do I know it's an organic acid? Anoic acid. What does anoic acid tell me? That at the end, I'm going to see this. This tells me how many carbons in the chain. 1C, 5 C's. So let's draw methanoic acid. I draw 1 carbon. On the carbon on the end. Well, like it's literally the only carbon, right? put the functional group. Okay, add any hydrogens that you need to. Well, this carbon has 1, 2, 3, so it needs a hydrogen. That's it. Pentanoic. 1, 2, 3, 4, 5. On the N carbon. I don't care which end you use. This time I'll use this one. Double bond O, OH. I just turned it into an organic acid, right? Now I need to add hydrogens. This carbon already has 1, 2, 3, 4 bonds. So this one. 1, 2, 1, 2, 1, 2, 1, 2, 3. There we go. Remember, don't forget to draw the lines. You can leave off the H's writing them, but you can't leave off the lines. Okay? All right, it's time for esters. So now I got to look it up again. All right, ester. Ether was just an O breaking up the chain. An ester has an O breaking up the chain, but it has a C with a double bond O immediately next to it. And here's the only thing. So I'm going to jot a note down right here. So when I name it YL, right? So carbon prefix, right? And then carbon YL, then carbon prefix, and O8. Okay, so just see what I just wrote down. Carbon prefix YL, carbon prefix anoate. Now, how can I tell which is which? So let's look at how they named this example. Methyl, so that's one carbon. Do you see the oxygen breaking it up? Propanoate. So this one with the anoate has the double bond O attached to it. So attached to this anoate is the C double bond O. Okay, so that will be important when we name. All right. So let's go through and find carbon-carbon chains. Well, here is a chain of 2 broken up. Then it's a chain of 3. So that's prop, that's F. Okay, so look at this one. We have a chain of 2, F, a chain of 1, meth. Chain of 2, F, chain of 2, F. Chain of 3, prop, 1, 2, 3, 4, a chain of 4, bute. Okay, so now that we have this, we can piece these together, easy peasy. So look at this one first. I need whatever my prefix is, they just go in this blank, right? What I have to make sure is the one that has the double bond O gets the anoate. So that one has the double bond O, right? So it's propyl ethanoate. Okay, let's look at this one. Which one has the double bond O? This one. So that goes here. So this one is methyl ethanoate. All right, what about this one? Which one has the double bond O? This one. So this one is ethyl ethanoate. Lots of ethanoates, right? Now let's look at this one. Which one has the double bond O? The prop. So it's going to be butyl ethanoate. So do you see this note right here? This will help you if you make notes on your reference table or write on your exam as you're doing it. Trust me. Okay, so remember I already did this for esters, so let's use that information when I draw this. So eth means how many carbons? 2. Prop means how many carbons? 2. Pent means how many carbons? 5. Hex means how many carbons? 6. Well, ester means I have a functional group that looks like this. C double bond O and then an O breaking it up. So I can start with just the O, right? And then on one side, I'm going to put 2 C's. On the other side, 1, 2, 3, 4, 5. Okay. But because this is the anoate, this double bond O, right, goes on that carbon. So it goes here. So I can simply put the O, put 2 on this side, 5 on this side, put the double bond O where it belongs. Now add in the hydrogens. Remember, oxygen is only 2 bonds, so please add nothing. This carbon has 1, 2, 3, 4. Done. And then, like normal or usual, the middle ones get 2, the end ones get 3. So let's try this one. I have 2 carbons on one side, 6 carbons on one side. On the side of what? That O that broke up the chain. So I have an O that broke up the chain, right? And on one side I have 6. 1, 2, 3, 4, 5, 6. On the other side I have 3. The double bond O is attached to the anoate. So that's the chain of 6. So that's this one. Then we go in and we fill in all of our hydrogens. Remember, if you don't fill in the hydrogens, your drawing, your sketch, your structural diagram is incorrect. You must put in the H's. All right, there we go. That's esters. Okay, phew, I know this is a lot, but we're almost done. So amine. All right, let's look at table R to see what amine is, because I have 2 that are very similar. See, amine and amide. Amide is next. Amine just has an N, right? Amide has a C with a double bond O. So I just got a carbon chain and I've got an N stuck somewhere. And notice I have to use an address. Okay. So let's look for carbon-carbon chains right here. Here. That's a small chain. All right, now let's look for anything that is not a hydrogen that's attached to that chain that makes a functional group. All right, we need to know how many carbons in the chain. So 2 is F, 4 is bute, 1 is meth. Okay, let's look at the name again. So I need an address, carbon chain 1, 2, 3, and then an amine. It's literally an amine. So it's how many carbons? 2 and amine. It's literally an amine. Okay, this would be bute and amine. This would be meth and amine. Now, one of them needs an address. Do you know which one? Okay, let's think. Well, meth and amine. Is there anywhere else to put this? No. What about ethanamine? Does it need an address? No, because if I put it on this side, that's still a 1, right? I can't put it anywhere else. But this one, I need an address. What address, what number carbon does this functional group belong on? Well, I could number this way and get 1, 2. If I number this way, I get 1, 2, 3. What's the lowest number? Going this way. So 2 butanamine. Okay, so now we're going to draw some. Ready? How can I tell it's an amine? It's an amine. It literally says an amine at the end, right? Bute means 4 C's. Hex means 6 C's. This means the functional group is on carbon number 1. The functional group is on carbon number 3. Okay, what is the functional group for an amine? NH2. So draw 4 C's. 1, 2, 3, 4. On carbon number 1, put in NH2. Then fill in hydrogens. Nitrogen can form 3 bonds, so 1 and then 2 hydrogens, that makes 3. So, but this carbon, this carbon, this carbon, this carbon. Let's try the next one. Hex is what it said was 6 carbons. On the 3rd carbon, 1, 2, 3, put an amine. Now just add your hydrogens. Be careful with this one. There we go. Okay, last one. Ready? Amides. Okay, let's look at it on table R. It's our last one. Remember we had amine, which just had a nitrogen stuck on the chain, but amide has a C with a double bond O attached to an N. So this, notice no address. That means it's going to be at the end. And just like amine was named an amine, this is named an amide. Like I don't know why they were so nice with that. So let's look at this one. Let's find carbon-carbon chains first. Okay, and then we'll circle anything that is not a hydrogen that's attached to that, making the functional group. Okay, there we go. So how do we name it? Name the chain prop and add an amide. 1, 2, 3, 4, 5, 6. Hex and amide. Meth and amide. Easy peasy, right? All right, this is it. This is the end. So anamide tells me it's an anamide, which means a C double bond O with an NH2. Okay, at the end. So first I draw my chain. Hept is 7. 1, 2, 3, 4, 5, 6, 7. On the end carbon, put the functional group, add the hydrogens. Easy peasy, right? Pent and amide. Pent. 1, 2, 3, 4, 5. Anamide means at the end carbon, so let's put it on this end just to show it doesn't matter which end I put it on. Okay? And then I still have to fill in the spaces with the hydrogens. And that's it. That's anamide and all of the other functional groups in Table R. So refer back to this video as needed to help you if you're drawing or naming.